Hello friends, welcome to quick fire numerical session in antennas and electromagnetics. Today we'll discuss numericals based on impedance of transmission line. Now if we talk about transmission line essentially has three impedances. The load impedance right here, ZL, the characteristic impedance of the transmission line, and the input impedance. Now, what is special about input impedance? It is calculated at every point on the transmission line from the load. For example, if I calculate the input impedance at this point, so I'll say that this input impedance is calculated at a distance L from the load for this transmission line. So in other words, we just have three impedances, and out of these we need to calculate this, so it is going to depend upon this and this. So the formula that we need to remember for gate examinations or any other competitive examination is this one: Zin is equal to Z0, and in parentheses we have ZL plus Z0 J tan beta L, and in the denominator we have this thing reversed, so Z0 is the real thing and ZL comes with the imaginary part. And by the way, we have tan beta L here. In the original formula it is tan of gamma L, but we assume in 99% of the cases that it is a lossless transmission line, so gamma being equivalent to alpha plus J beta, alpha is removed from here, and that is why this J has come here. So but this formula will work for 99% of the cases. Otherwise you could replace it with tan gamma L and remove this J and calculate gamma as alpha plus J beta. Now beta again is 2 pi by lambda, so substitute 2 pi by lambda here and you're good to go. So your input impedance can be calculated like this. So it is dependent upon two things, basically Z0 and ZL, and of course the distance. And let's see what kind of scenarios can pop up. We have this transmission line, the length is calculated from the load, and we could get two scenarios where the length could be given in meters or length could be given in terms of lambda. So in this particular video I'll talk about the case when the length is given in meters. So a typical question would look something like this: a coaxial cable, of course it's a lossless coaxial cable, with Z0, the characteristic impedance as 75 ohm, terminated with a load of 60 plus J30 here. Z0 is 75 and it needs to calculate the input impedance from 50 centimeters from the load, and the operating frequency is 1 gigahertz. The signal that it is carrying is of 1 gigahertz. So this 1 gigahertz is very important because this will give us lambda here. Once we calculate lambda, we need to put it back into beta, 2 pi by lambda, and calculate beta. From beta we need to calculate tan beta L, so beta multiplied by L, which is 0.5 meters here. So I'm going to calculate the value of tan beta L because it will be convenient for me to place this numeric value in this formula. And when I do that, I can simply calculate the value of Zin by putting Z0, ZL, J, Z0 multiplied by beta tan beta L, then Z0 again, and ZL multiplied by. Finally you would need to use calculator to solve this, and if you wish to be proficient in polar to rectangular formats working with complex numbers, you could watch my playlist on how to use calculators, especially Casio 991 ES and EX calculators, and they are going to be extremely helpful for you in this. So Zin is this, the imaginary part is negative, so it's a capacitive So we could generalize these cases like this. These are the 4 very famous cases where length could be integral multiple of lambda by 2 or odd multiple of lambda by 4 and so on and so forth. And further we could categorize these cases on the basis of what is the nature of ZL. It could be short circuited, it could be open circuited, or it could be a matched load. Short circuited means ZL is 0, open circuited means ZL is infinity, and Z0 means the load impedance is equivalent to characteristic impedance, which is perfect matching. I'll look into these cases and different lengths cases. We can make a table out of that, and if you wish to remember that table as well, you could do that, but otherwise this formula is sufficient in itself. And that's about it for today's tutorial. I hope you liked it. If you did, you need to click on that like button and hit the subscribe button as well. Share this video to the channel. Thank you very much. I'll see you. Bye.